This is our presentation on Bitcoin analysis for CSCE 440. My name is Adrian Choate.
My name is Victor Knapp.
I'm Pham.
I'm Ryan Argo. So our motivation. So recently, Bitcoin has hit nearly $100,000, and it is a digital currency that works with banks using blockchain technology. The motivation for using interpolation to analyze Bitcoin's monthly prices is to fill gaps between data points, visualize continuous trends, and understand price behaviors despite volatility. Knowing this information will allow us to form a better idea of Bitcoin's trends for future analysis. And this is where we got our data. As you can see, it's the last year or so, last 4 years.
All right, so the first method that we used is piecewise linear interpolation. So piecewise linear interpolation approximates a function by connecting known data points with straight lines. It's super rigid, but it is a very common method that people use, and it's fairly efficient. Each interval between points is treated as a separate segment with a linear relationship. Again, it's just a line between 2 points. This is the code that we used. It is written in MATLAB. We decided to use it because it's just something that we are familiar with. So on the top left there, that is, we separated the data into 60 months, which is, 12 months out of the 5 years. And so each number up there is the average number the price of Bitcoin hit in that month. The bottom left is the function for the piecewise linear interpolation. And on the right, you can see that it is a graph with the blue dots being the original data and the red lines being the interpolated data there. Our second method is cubic spline interpolation. Cubic spline interpolation is a mathematical method that tries to approximate values between known data points in a smooth, continuous way. So much like piecewise linear interpolation, it is trying to find data in between 2 points, but instead of just having a straight line, there is more of a curve to it because it uses polynomials and can figure it out in that way. It constructs a series of piecewise cubic polynomials, like I just said, between each pair of data points in such a way that the resulting curve is smooth at the data points. And here is the MATLAB code for cubic spline interpolation. At the top left there, we have the matrix and the vector, and then the bottom left is the actual function that solves for within the matrix there. And on the right is the same graph with the blue dots representing the original data and the red lines look a little bit more pink here, being the cubic spline interpolation. So you can see that it's a little bit more curved at the tops there. And what's actually interesting is that those curves at the tops are a little bit more accurate and represent the actual data.
Okay, then for our last implementation, we use the Lagrange interpolation, which approximates the function by using a set of weighted sums of polynomials on the known data points. Each polynomial is constructed through a single data point, and the overall approximation is a combination of all the polynomials. It's pretty similar to the cubic spline in that it's not direct lines, but it can be a little inefficient for using the approximation for certain data sets due to oscillations between the points. Then here we have the MATLAB into implementation on the left, and then the results that we got on the right hand side with the red lines showing the polynomial. And as you can see, we got oscillations during this implementation, and the blue dots being the original data. Then for these results, we compared the analysis or the implementations with only using the original data set, and then 75% of the data set And as you can see with the piecewise interpolation, it's kind of similar. However, we do miss more specific chunks in the data. And here we have the cubic spline interpolation, which shows the general trend as well, similar to the last one. But with 75% of the data, it's unable to get the better, more finer curves, but still getting the overall trend correct. Then with the Lagrange interpolation, the oscillations are a little spaced out. However, for the data closer to the center of the data, it's quite accurate for the general trends given the data that there is.
For our conclusions, for analyzing Bitcoin prices, cubic spline interpolation was the best choice. It provided more smooth curves and captured the long-term trends, balancing accuracy and continuity. This is ideal for Bitcoin's volatile yet trend-following nature because having more curves at the tops and the bottoms of the graph would lead to better results and approximations for the future. And then piecewise linear interpolation is too simplistic and rough, while Lagrange interpolation is impractical for large or noisy data sets due to oscillation.
All right, that is our presentation. Hope you enjoyed.